Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will talk about the quantity of water, cement and sand. Okay, it's very important in plastering. Okay, plastering, it's very important. Plastering. Okay, we use plastering in our house. Okay, in residential building, in commercial building, whatever. The plaster we apply, it may be wall, okay, or it may be ceiling. You got it? It may be wall or it may be ceiling. Now we have a general formula for general ratio for wall. If we talk about for a wall plaster, the ratio we use generally, it is 1:6. okay, this is 1 part of cement and 6 part of sand. Got it? Mostly generally we take it for wall plaster. If we talk about the ceiling, for a ceiling the ratio is 1:4. okay, now we will find out what will be the quantity of water, the quantity of cement and the quantity of sand. Okay, I will take example. Okay, this is the example. If the area is 100 meters square, okay, this is the area of wall. If the area is 100 meter square, this is the area, and the thickness, as I told you earlier, the thickness we generally take, it's 12 mm for wall, it's 12 mm, and it's for ceiling it goes up to 6 mm, but we talk here about the wall, it's 12 mm. okay, the thickness of plaster 12 mm. If we convert it into meter, it becomes, we divide just 1000 and we got 0.012 meter. So what is the ratio? Ratio we know for wall is 1:6. okay, now we will find first the volume. What is the volume? And remember one thing, the volume, we know volume is area upon thickness. Area we have here 100 meter square, and the thickness we have 0.012 meter, and so the volume becomes 1.2 cubic. So this is the volume. So our volume is 1.2 cubic. So remember one thing, this is our wet volume. What? This is our wet volume. So guys, remember this thing, we have two types of volumes in plaster. We have two types of volume. In plaster. One is called wet volume, and the second is called dry volume. Okay, one is wet volume and the second is dry volume. So our volume was 1.2 cubic, it was wet volume. Okay, so dry volume will be 1.2. Dry volume will be 1.2 into what we multiply 1.33. okay, here where from this comes 1.33? We have some basic concept. This 1.33 is constant. Okay, constant. So we always multiply 1.33 for dry volume. So actually this is a constant. Actually this is due to the bulkage of sand. This is due to the bulkage of sand and it is bulkage of sand and wastage of sand. Wastage of sand. Okay. And actually what happened, 33% of volume we increases from wet volume to dry volume. Okay, this 1.2 was our wet volume, so we increased 33%, that is 1.33 for dry volume. Okay, this is the dry volume. So if we multiply 1.2 into 1.33, it becomes 1.596 cubic. So this is dry, this is our actual volume, dry volume. You got it? This is our dry volume. Now it's very simple and easy. Now we will just find the quantity of cement, quantity of water and quantity of sand. First we will talk about the quantity of cement. This is a quantity of cement. Okay, first we will talk about the quantity of cement. What we have to remember, we have remembered only one thing. What was our dry volume? Dry volume was 1.596 cubic. So dry volume was 1.596 cubic. Okay, now we will find the quantity of cement. Quantity of cement will be volume, that is dry volume, you know that it dry volume, multiply by density of cement. Okay, multiply by ratio, divide by sum of ratio. Simple. Okay everyone, now first, what is the dry volume? Dry volume is 1.596 and the density of cement is, we know, everyone know density of cement is 1440 kg per meter cube. Okay, and the density of cement is 1440 kg per meter cube, and the ratio, we use ratio here for wall, it's 1:6, one part of cement, so ratio is 1, divided by the sum of ratio is 6 plus 1, that is 7, divided by 7. Okay, it becomes 328.32 kg. Okay, we know one bag of cement is equal to 50 kg. Okay, so we will convert it into 50 in bags, divided by 50. Simple. Now what we got 6.5 bags approximately. 6.5 bags approximately, 7 bags. So we need 7 bags of cement for 100 meter square wall. So area is 100 meter square wall. So we need 7 bags of cement for 100 meter square wall, and where the thickness is 12 mm. Okay, this is the quantity of cement, 7 bags. You got it? This is the first one. Now similarly, we will find the water. Water is very important. Water. Okay, as far the water is concerned, there are general two things I wanna discuss here. There are general two things for water. For calculation of quantity of water, there are general two things. If we talk about the ratio, that is, which is the general ratio, 1:6. Okay, what we assume, we use 0.6 liters of water, 0.6 liters of water, 0.6 liters of water. This first one, 0.6 liters of water is equal to 1 kg of cement. Okay, this is first thing. This is first one. 9.46 megapascal is the strength. Okay, so actually these tests have been done by sand testers. So here we remember the general rule, that's for 0.6 liters of water we use 1 kg of cement, and we got the strength 9.46 megapascal. Second, we have, if we use 0.7 kg 0.7 liters of water for 1 kg of cement, we got the strength we got here is 10.76 megapascal. Okay, this is the strength we got. For 0.7 liters of water we got 10.76 megapascals of strength. So here we will use the second one, 0.7 liter. Okay, so the strength will be more. So simple, what we have to do for calculating the quantity of water, we just first take the kg of cement. What is the total quantity of cement? So as you know, the total quantity of cement is 328.32 kg. So 328.32 kg of cement into 0.7 liters into 0.7 liters. So we got 230 kg. That is 230 liters. So it is actually 1 kg is equal to 1 liter. Don't confuse here. Okay, now we'll talk about, approximately we take the 7 bags. Okay, this was here the total cement was 7 bags. Okay, for 7 bags what we do, it was 350 kg. Okay, multiplied by 0.7, that is equal to 245 liters or kg of water. Okay, so the quantity of water is, so quantity of water is 245 liters. Quantity of water is 245 liters. Okay, this is the second one. Okay, and it is actually the 245 liters of water we need for 100 meters square of wall having thickness 12 mm. You got it? Okay, now similarly we will find the quantity of about sand. We will find the quantity of sand. Sand is similar to cement. Okay, so what we do to find the quantity of sand, what we do, we all know the total volume, the dry volume. The dry volume we have here 1.596 cubic. So we just, for calculating the quantity of sand, we have the first dry volume into, we know 1 meter cube is equal to 35.31 cubic feet, because whenever we go for a market, we go for to purchase a sign, it is always in cubic feet. Okay, CFT, cubic feet, 35.31. 1 meter cube is equal to 35.31. We know this thing. So here dry volume we know, multiply, we will convert it and multiply by the ratio, you know, ratio of sand. The ratio is 1:6. This is cement and this is sand. Ratio of sand is 6, divided by total ratio. Total ratio is 1 plus 6, that is 7. So the dry volume was 1.596 into, we will convert it into cubic feet. So we have to multiply 35.31 and the ratio is 6 divided by total ratio, that is 7. So the quantity of sand, in cubic feet will be 48.31 CFT. This is the quantity of sand. Okay, so guys, for 100 meters square of wall having 12 mm thick plaster, we first need the quantity of cement. We need 7 bags of cement. 7 bags of cement. Second, we need the cement, and the second we need the water. The water we need is 245 liters of water. 245 liters of water. And third, we need sand. Sand we need 48.31 cubic feet. Okay, thank you for watching.